All right, so we'll start off with question number 3 from the FRQs. And up above we have a graph of f, and they tell us that f is a continuous function on the interval -6 to 5. And the given figure shows a portion of this graph. So notice they told us it was continuous from -6 to 5, but we only really see from -2 to 5. With that being said, it says it consists of 2 line segments and a quarter of a circle centered at the point 5, 3. And then it's also known that the point 3, 3 minus root 5 is on the graph. So this y value right here is evidently 3 minus root 5. So without further ado, let's dive in. For part A, actually, I'm gonna have the scoring guidelines below where I can see them as I go. For me, just to make sure I do these right the first time. Okay. So up first, I guess let's read it like this. If the entire integral of f is 7 overall, find the value from -6 to -2. Find the area under the curve from -6 to under -2. In other words, what that means is if you know that all this area plus this area equals 7, what I need to do is figure out the area underneath this whole curve and then subtract that from 7, and then I'll know how much is there. The other key idea is that from -6 to -2 for f of x, dx plus -2 to +5 f of x dx equals -6 to +5 f of x dx. This is one of the algebraic properties of integrals. So in other words, an entire interval can be broken up into 2 or even more pieces, and the key is that one of them has to end where the next one needs to begin. So anyways, we need to calculate this area. We already know this whole thing is just 7, so now let's work on calculating this chunk. I'm going to do some advanced techniques, but follow my mouse here. The idea is, for this first segment, you essentially have the area of this triangle that's above the x-axis, and then you have this triangle that's below the x-axis, and if you think about this geometrically, those are going to be the same size triangles, so those positive value since it's above and that negative value since it's below cancel each other out. So far from -2 to 0, collectively there's 0 from the integral being added on. Similarly, from 0 to 1, there's this smaller triangle below. It's equivalently that same length or same size triangle above, so the area of that collectively is 0. So far from -2 to 1, if you sum up everything below and above, you're just going to get 0. So after that, now we have this area above that's actually going to start to give us some value. So from there, the first shape I see here is a trapezoid. And so that trapezoid formula is 1/2 times the height, or in other words, times the horizontal movement, which is 1, times base 1 plus base 2, which is actually the heights of the function. So the first base is 1, and the second base is 3. When you work all this out, that trapezoid has an area of 2. Now I've said this before, but there's another way of considering this. If you were to take this triangle and it were to fold in, it would collapse and fill this square perfectly. So you would have 1 square and 2 squares perfectly. You can definitely do some geometry tricks here as you find the areas. And now we have the quarter circle. And the trick to this quarter circle is it's not that I want the area of the quarter circle, it's that I want the remaining little I don't even know what to call this, kind of arc, half rectangular shaped figure. We want that area. How are you going to find that area? Well, let's think about the fact that maybe you can see this square right here. This whole square is 3 by 3, so it has an area of 9. and we're going to subtract the quarter circle area. And this quarter circle would be 1/2 pi r squared, or 1/4 pi r squared, and r in this case is 3 if you look at that circle. The radius is 3, I only want 1/4 of it. So far, again, we've got the trapezoid area of 2, we've got this area, let me work that out, it'll be 9 minus 9 over 4 pi. And really, that's about the best I can write this. So far, if we add this collectively together, here's what I end up with. The integral from -2 to 5 is actually, for f of x dx, is going to be 11, because the 2 plus 9, minus 9 over 4 pi. Alright, so now, again, the idea is from -6 to -2, that's what we want. Dx. We have, this whole thing is now equal to 11 minus 9 over 4 pi. The other side is equal to 7, so I need to subtract that integral over. So in other words, this answer is 7 minus the 9 minus 9 over 4 pi. And you can simplify that, but I'm just going to stop there for the sake of time. It's already been 6 minutes, and I've only gone over one part. Let's hope I can do the next part faster. Up next, they want me to evaluate b, and let's see here, when I integrate from 3 to 5, 2f prime of x plus 4 dx. When you integrate 2f prime, you're going to get 2f of x. That's part of the fundamental theorem of calculus. When you integrate 4, you're going to get 4x. So two definitely different types of integrating going on here. The first is fundamental theorem of calculus. The second is just actually regular integration. And this is being evaluated from 3 to 5. Oh wait, you know what? I just realized I made a mistake up here, because the collective area was 11 minus 9 over 4 pi. Alright, anyways, back to it. So when I plug this in, the idea is the answer is going to be 2 times f of 5 minus 20. Maybe I don't need parentheses here. I have 2 times f of 5 minus 20 when I substitute the 5 in, minus, now I need parentheses, 2 times f of 3 plus 12. I'm making mistakes all over the place. It should be 2f of 5 plus 20, then the minus for the whole integral, 2 times f of 3 plus 12, and that minus will distribute. Sorry, I'm making a lot of silly mistakes as I talk through this. Alright, so from there, what is f of 5? Well, if you look at the graph, f of 5 is 0, so far this is just 20, because this is 0 plus 20, minus 2 times f of 3. What's f of 3? Oh no, f of 3 isn't directly on the graph, but wait, that's what this piece of information was all about. So it's 2 times 3 minus root 5, so another way we could write that is 6 minus 2 root 5, and then we still have that minus 12. Alright, so I'm kind of not distributing the negative yet, and I am distributing it there. When we simplify this all together, we'll have 20, we'll have a negative 6, and we'll have a negative 12. So that's actually just going to end up being 2, and then we have positive 2 root 5. Alright, part C. So we have function g is given by essentially an integral that has f of t, and we need to find the absolute maximum of g on the interval -2 to 5. Okay, how are we going to do that? Well, if I want to find the absolute maximum of g, I need to find the critical points of g prime. And remember from the fundamental theorem of calculus, g prime is actually just going to be f of x times the derivative of x times the derivative of the upper bound of the integral, so that's just going to be 1. So really the question is, where is f of x, or g prime of x, equal to 0? And f of x is the one I can actually investigate because I have its graph. So where is f0? Well, that happens at x equals -1. and it also happens at x equals 1/2, and it also happens at 5. And so now let's kind of look at our sign chart here. So for f of x, we have -1, we have 1/2, we have 5. To the left of -1, f is positive. To the right of -1, it's negative until we get to 1/2 and it becomes positive again. And then from 5, well, it's just 0. And the point is to find the absolute maximum on g. And so that means it could be two things here. It could be this critical point right here, or it could be at 5. Right? In other words, I know it's not at -2 because from -2 to -1 it's increasing. So in other words, at -2 it's not going to be the maximum if it's getting bigger as it goes towards -1. So it could be x equals -1, it could be x equals 5, and now let's think about this. Whatever value g was at -2, it's really only increasing by 1/2 by the time it gets to -1, half of a full unit. And so that's not that much increase, and then it's decreasing for another half unit. So in other words, by the time you go from -2 to 0, you're back where you started. And then by the time you get to 1, you're still back where you started. But think about this now. The value of the function from 1 to 5 has all this increase, all this positive area underneath. And so that means 5 is going to be where the absolute maximum occurs. All right, and they just simply want me to, never mind, they want me to find the absolute maximum value of g. So again, we have our candidates here, and really you should only write down that -1 is a candidate. So we should, essentially, the other way of validating this is you should get to these two choices. From there, the question is, well, what is g of -1? And that means you have to actually calculate the value of the integral, if you can. So what's g of -1? Well, g of -1 is actually the integral of f from -2 to -1, and that answer is just 1/2. And then the question is, what is g of 5? And that means what is the integral from -2 to 5? And you've actually already calculated this. The value of this integral from -2 to 5 is 11 minus 9/4 pi, which, trust me, ends up being more than 1/2. All right, one more part. Up next, we have to evaluate a limit, and long story short, when you evaluate this limit, you're going to be in a L'Hopital's rule situation. Actually, we might not be in a L'Hopital's rule situation. Might be looking too quick. So when we try to plug in 1, we're going to get 10 to the first minus 3 times f prime of 1. So that means look at the graph at 1. What is the slope? And if you look at this slope, it's rising 2. It's going right 1. So f prime at 1 is actually 2. Positive slope of 2. Divided by f of 1. What is the y value at 1 for f? That's actually just 1. Minus arctan of 1. Remember that arctan of 1 is saying where do you get a tangent value of 1, and that happens at the radian pi over 4. All right, so we end up having essentially here, this is going to be 10 minus 6, which is 4, over 1 minus pi over 4. Another way of writing 1 minus pi over 4 is 4 pi over 4 minus pi over 4. In other words, a whole pi with 4 pieces minus 1/4 of a pi. You'd be left with 3 pi over 4. And if you work that out, actually they stop kind of right here. They stop at 4 over 1 minus pi over 4. But if you wanted to keep on going, it looks like that could also be written as 16 over 3 pi. Let me make sure about that. 16 over 3 pi.